Hi everyone, good morning. If you're on the West Coast, good afternoon. If you're on the East Coast or further east than New York, welcome to another one of our Wallaroo Community Tech Talks. We run these every 2 weeks and we get into a technical topic. And so we do a quick deep dive for 30 minutes when we try and keep this interactive with Q&A, and we'll have some time at the end for that. And today's topic, we will be going through how you detect ML model drift and how you act on that, because we know that once you deploy models into production, that's not the end of the journey. You got to keep these models up and running and making sure that they are, proving the value and the effort that you put into them, and making sure that they're paying back to the organization. At Wallaroo, we are a production ML platform company. We're a Series A startup, and so our product helps you get your models into production, and then manage that post-production process of model monitoring, observability, and making sure that that they are working in the way that you want them to, in an environment that's comfortable to you, whether that be UI, SDK, or the number of APIs that we have that plug into existing investments that you have already. And so today's topic, as I mentioned, is about model monitoring and observability. We'll talk about why we need model monitoring. What is model drift, different types of drift, and then how do we handle those situations at Wallaroo. And we'll go through a demo as well, just to show you what that looks like in action in the Wallaroo platform. My name is Martin Bald. I'm the Senior Community Manager at Wallaroo. As I mentioned, I run these every 2 weeks. We record them and we put them up onto our YouTube channel. We also have a free community edition where you can download, go through tutorials and get some hands-on learning, and give us feedback as well on how the product is performing and what improvements we need to make. We know that our product is, we think is in a good shape, but it's always good to get feedback from the community and experts such as yourself to let us know, what happens in the real world and how do we need to improve the quality of the product and also the documentation as well. I'm going to hand it over to my colleague. Wani, you take it away.
Hey, Martin, thank you for setting this up. My name is Vani, and I'm a product manager at Wallaroo. Thank you all for joining our tech talk this week. Let's dive into it, and we will start with what is model monitoring, what is model drift, and why is it important to monitor your model in production. We have often seen companies spending a lot of time and effort on training and deploying the models in production, but once the model is deployed, model monitoring often gets sidelined. It is very important to monitor the model, as conditions that existed when the model was built, trained, tested, and deployed can change over time due to various factors. Too many changes in these factors can cause performance issues with your model, where it's not making accurate predictions anymore. And this is when we know that the model is drifting. Another way to identify there is a drift is to compare your model's predictions with the actual outcomes. This may not always be possible and have too much of a lag. And if we do not identify a model drift in time, this can lead to inaccurate business decisions being made. So how do we experience these drifts? We can go to the next slide, and I will show it to you in a minute. How we experience drift, there are 3 common patterns for it. I'll be talking about abrupt drift, gradual drift, and reoccurring drift. So abrupt drift is when things change overnight, causing your model to drift. A pandemic like COVID is a good example for this, where you suddenly saw people buying office furniture to set up a home office and everyone working from home. During pandemic, we also saw a demand and supply issue for face masks because of COVID. A lot of people were ordering face masks, and because this was an abrupt drift, there was a shortage in the mask as well. Gradual drift is when things start changing over time, causing your model to drift. An example for this can be drop in the sales at movie theaters because of OTT platforms like Netflix and Amazon Prime. A good thing is to study this drift, and I like what AMC did after by introducing AMC Movie Pass. They changed their business strategy and tried to increase their sale again. Reoccurring drift is also called as seasonality, where a drift occurs for a certain period of time and then the model goes back to normal. A good example for this is ice cream sales. So the ice cream sales go down in winter, but then they go back to normal during summers. That's an example of reoccurring drift. There are different types of model drifts. I'm going to talk about data drift and concept drift. Data drift is caused when the data a model is trained on changes. That is, the input data isn't distributed the way it used to be or as defined by the baseline. A data drift can occur due to errors in data processing pipeline or due to changes in the environment, such as user behavior. I'm going to use a real estate example for this. It's my favorite example. Imagine you have a real estate model, and this model shows distribution of houses based on bedrooms and bathrooms in a particular neighborhood. So when you deployed this model to production, you were aware that there's an ongoing construction that's happening in the neighborhood, and suddenly your model starts showing more, say, two-bed, two-bath apartments. This is happening because the construction just completed. So this is a data drift, but you probably do not need to retrain your model as the other conditions haven't changed. The construction was completed, and that's why you see more of two-bed, two-bath houses in the market. Concept drift is when the world doesn't work the way it used to. So the patterns that the model learned from during training may no longer apply. This is usually an unforeseen change. So you can think about driving patterns or commute patterns pre versus during versus post pandemic. If you have a model trained on commute patterns in 2019, that won't necessarily apply to 2020. And the patterns from 2020 do not apply today. That is an example of concept drift. I am going to use a real estate example for concept drift as well. So imagine you have a house price model that predicts home sales and prices, but it's starting to drift and it's showing a drop in sales and it's also showing a drop in home prices. Now, the environment that the model was trained on had different interest rates. Now the interest rates have increased, and that is causing more people to not qualify for the mortgage like they used to. It is also causing the home sales to drop because of affordability. And this is an example of concept drift. You might have to retrain your model based on these new factors. Let's talk about what Wallaroo's solution is for model monitoring, drift detection, and what are some of the next steps that you can take when you observe this. So at Wallaroo, we have created model monitoring tasks called essays as a part of Wallaroo Suite. Now, essays help you monitor how the environment that your model operates within changes in ways that affect the model's outcome. It monitors a model's predictions or the data coming into the model against established baseline, and changes in this distribution of data can be an indication of model drift. This can provide you tips on whether a model needs to be retrained or the environment data needs to be analyzed for accuracy. Having this information allows you to intervene and retrain your model in an efficient and timely manner. So what happens after you have observed this drift and you have retrained your model? You should it's always a good idea to test this new model against the one that's already running in production. Now, this is your retrained model that you want to bring into production. So you want to do some A/B testing on it just to make sure that the new model is giving you better predictions because it's trained on the new environment factors than the model that's already running in production. Uh, Wallaroo offers A/B testing for this particular case where you can test both the models, look at the logs, look at the predictions from both the models, and efficiently decide which model you should send to production. And before we commit to new model, I think we should make sure that the new model behaves in real world data. We can do a shadow deploy and validate results by sending all the data to the current model and the new model and make sure that the new model is working when all the real world data is sent to it. Some people also do shadow deploy to do a sanity check on their model behavior by comparing their actual or active model against a simpler but more robust model, like a linear regression model. So, a linear regression model will often make a prediction that's in the ballpark, but it won't be exact. If you have an actual model that makes a prediction that's way different from the linear shadow model, this might be a sign that the model is starting to drift or it made a bad prediction. Next, this is all the talking, but let's look at the demo.
Awesome. I'm going to stop sharing, Wani. I'll hand it over to you so that you can continue on. Just folks in the chat window, you can, like I mentioned at the beginning, you can get this, the community edition for free. And you can run through the demo as well, that tutorial that Wani is going to show now. Back to you, Wani.
Thank you. So what you see here is Wallaroo's model insights dashboard. You go to your pipeline and you go to Insights tab. This is where you can create monitoring tasks or essays. I already have a few essays that I created. That's why you see it here on the list. You can also search the essays by name. You can filter them based on the status or sort them by creation date. Let's create a new essay. For that, click on Create Essay. Let's give this essay a name. Okay. You can select between input and output monitoring. For the purpose of this demo, let's go with the output data. I'm going to select the names field and index that I'm going to monitor. Next, we specify a baseline. So baseline provides a set of records where the data is known to be typical. And this is how we can determine that the distribution of the new data has changed. I know that for this model, we have good data from January 1st and January 2nd, and then we can see distribution visualization for the data here. Next, we will use these inference results from January 1st and compare it to all the other days' inference results in the upcoming week. We are going to use population stability index score to determine if we are experiencing a drift. The PSI measures how much data has drifted between the baseline and the subsequent days. We have plotted PSI scores and it is represented by the green dots that you see on this graph. The red line at the top is the threshold. When PSI breaches this line, the model is experiencing a drift and it will trigger an alert. You can hook this up to your production monitoring services to take an appropriate action. Under advanced settings, you can set the binning scheme. I have it set to quantile binning that defines the bins using percentile ranges. Equal binning defines the bins using equally spaced data value ranges like a histogram. You can also set custom binning based on your business needs. Metric, we use this to specify the metric, and by default, we are using PSI. This is an entropy-based measure of the difference between distributions. Other measurements that you can use are the maximum difference of bins, which measures the maximum difference between baseline and the current distributions. And the last metric available is sum of the difference of bins. This sums up the difference of occurrences in each bin between the baseline and current distributions. You can also specify a threshold here. The threshold decides whether the difference between distributions as evaluated by the matrix is large or small. The default of 0.1 is generally a good threshold for when PSI matrix is used, so I'm going to go with 0.1. Let's finish and create the essay. You can see that the essay is created. Now let's look at the data and see if there was a drift. Let's look at the month of January. So, yeah, as you can see, the model was working fine, but after January 14th, it started to drift. Since we have identified a drift, we should go and retrain the model. We should look at the factors that might have caused this drift. And I'm going to demo how we can do A/B testing and shadow deploy once the model is retrained. I have a Jupyter notebook here, and I'm going to import some libraries that I will need for the demo. Once the libraries are imported, I am going to connect to the Wallaroo instance. It's asking me to log in. So you have to authenticate, and this feature makes sure that only people who have access can make any changes or run the notebook. Once I have imported everything and I'm logged in, I am going to define the workspace. So you can see I have all my models, I have my files and artifacts that I need. I am going to set my current workspace to house price WSS. And I've done this a few times. That's why you see the name house price for the workspace multiple times here. Next, let's upload our control and challenger models that we'll be using for A/B testing. I'm going to build a pipeline and first start with my current model that is in production, that is the control model, and see the type of predictions that it's making. For this, the model should determine the house price around 700,000, and we can see it's at 718. Next, for this inference, the model should identify house price around 1.5 million, and it's 1514079. This is in the output that you can see. Now that I know that my control model is working, I'm going to send 1,000 inferences and show you a few results so that you can see what it looks like. You can check the timestamp, you can see the input and the output from the model. You can check anomalies as well. There hasn't been any failures. Let's do A/B testing. So for A/B testing, I'm going to define an A/B test pipeline, and I want it to do a random split where I'm going to send 1/3 of my data to the challenger model and 2/3 of my data to housing control model. It's going to deploy. Now, this is one of the really good features or the highlights of Wallaroo. I did not even finish talking about pipeline, and you can see the pipeline is already deployed. Let's run a single inference and look at the results. So you can see that the data is going to control model, and the output, I'm going to run it a few times just to show how the data goes to control model. Okay, it shows you the model split, it shows you output that the model is predicting, and you can see the data went to housing challenger model as well as housing control model based on the split that we defined, and you can see the output from both the models here. Now that I know that the data is going to both the models, I'm going to run an batch inference of 1,000 records just to see if the split is how we defined it to be. And as you can see here, 2/3 of the data is going to housing control model, and 1/3 of the data is going to housing challenger, just like we defined in the pipeline. We know the split is accurate, and we know the data is going to both the models and they are giving predictions. Then let's look at the mean prediction for both the models. You can see the control model is predicting it to be 541388, and the challenger mean prediction price is 539660. Let's look at the logs. I'm going to limit it to 5 logs for now, because I've sent 1,000 inferences and I don't want to look at all the 1,000 records at the same time for the purpose of this demo. So you can see that the data is going to housing challenger, it's going to housing control, and the predictions made by both the models. I'm going to undeploy the AB pipeline before I talk about shadow deploy, just to give resources back for Wallaroo. Shadow deploy is where you send 100% of data to your control model, but the same data is going to your challenger model as well at the same time. This is how you can identify if you can compare the model's predictions when all of the data is sent to both the models in the real world. For this, I'm going to define a pipeline. And as you can see, my pipeline has shadow model first, and it's followed by my control models. And the data is going to go to all the models for prediction. I'm going to deploy this pipeline. Let's run a sample inference and see what it looks like. So as you can see, all the data at the same time went to my control model, but in the background, it also went to my challenger model. I have challenger model 1 and challenger model 2, and you can see the prediction made by all 3 models at the same time. Let's run a batch inference. I'm going to send 1,000 inference requests, and I'm going to display a few here. You can see the output prediction from the control model that is in production right now and the challenger models. You can then compare these results to what is actually happening, and you can determine which model is working better. Let's look at the logs for all the 3 models and see what they show. As you can see in the logs, I can see the prediction from all the 3 models. I'm going to undeploy this pipeline now. You now have all the data you need from all the 3 models to make an accurate decision and decide which model you should go with. Okay, over to you, Martin.
Fantastic. Thanks, Wani. That was great. And really showing how you can make sure that you keep on top of those models that you have in production, keeping them performing the way that you're supposed to, and then also any other models that you have that you'd like to pitch up against them to see if they're performing better. Is some really good tools doing that in production. So Wani, I got one question in here. So there's a lot of tools out there available to folks to do this model monitoring and observability. Now, how do we compare to those models and what other folks have available to them?
That's a good question. Thank you. So most model observability solutions that are available in the market today require you to download the model, download the data, transform it, and make it ready for model observability. This means an additional layer of operational overhead with data engineering required to get the data to a point where it's actually model observability ready. And if you have a single data scientist responsible for hundreds or thousands of these models that might be running in production, they probably don't have enough time or resources to do offline drift analysis for all the models. This effort can take weeks or months of time, and that's the time that your customers don't have. The data becomes highly volatile and the model starts to drift, which can have serious business impacts. With Wallaroo's Model Insights framework, they can create essays to set up ongoing monitoring and be alerted when there is a drift detected in any of the models that the essays are set up for. And once the drift is detected, you can take the next steps. Now, the good thing about setting up essays with Wallaroo is that it is integrated in the platform and it runs with the pipelines. So you get instant insights instead of downloading the data and going through all the steps that I just mentioned.
Awesome, great. I think the other question is, in seeing the, the ability to do that model comparison with A/B testing and shadow deploy, what happens if the challenger model is a better performer than the control model? What do you do then? Like, how do you bring that model into production?
Oh, that's a really good question. So once you compare the data and you know what model is working better, you can do a hot swap, which is a feature at Wallaroo where you can bring the new model to production by hot swapping it with the current model without any downtime.
Fantastic. Yeah, and I think that's really important. Like you showed in the demo, the ability to get your models into production in 45 seconds or less is very different from the reality that some folks are facing, where it can take days, weeks, or longer. Giving the different tools that they have to piece together, and then making sure that that environment is up and running, and you have that continuity and the ability to hot swap those models in and keep the business moving in the right direction. So yeah, great to see that. Folks, I don't see any other questions, but we have on the screen here, I got some other resources that are available to you. I popped them into the chat, and if you're watching this on the YouTube recording, great to have you here. If you want to like and subscribe and then see all the other content that we have already and will be coming up in the future. Again, get hands-on with the community edition, and we won't be sending you sales calls or anything like that, so no worries there. And we have a wealth of information in our docs page as well for tutorials, SDK installs, integrating with Azure Databricks, AWS SageMaker, and Vertex as well. And so making sure that we have that better together capability within that. Finally, I just want to say a big thank you to my colleague, Wani, for taking us through model monitoring and observability. Great to see the capabilities and that post-production environment, making sure that our models are performing in the manner that we expect them to. And looking forward to seeing you in a couple of weeks on our next Community Tech Talk. Thanks very much and have a great day. Bye-bye.
Thanks. Bye.